Okay, so today we are going to start looking at, or finish up looking at other climate influences. We started off talking about the latitudes of Earth, then we discussed the atmospheric currents and how heat transferred there. Today we're going to talk about other currents and heat transfer. So we're going to start off with reviewing the term specific heat. So if you went back to your notes from atmosphere, you'd remember the term specific heat is the amount of heat that is needed to raise one temperature of a kilogram of a substance by 1 degree Celsius. In other words, how much does it hold on to heat? How much does it transfer heat to other areas? So when we talked about this, we did that aluminum oxide and aluminum rod demonstration at the front with the metal rod and the ceramic rod. And we noticed that the heat went through the metal rod much more quickly than the ceramic rod. It traveled more because the metal has low specific heat. It doesn't hold on to heat very well. It's a good conductor. Whereas the aluminum oxide, the ceramic rod, held on to it for a long, and it was actually hard for us to get those candles to melt off of that one. So that's why we use ceramics to help with our as mugs to help keep our coffee and tea warm and that sort of thing. Okay, so but another thing, not just ceramic has high specific heat, but water also has a very high heat, which means it holds onto energy or heat very well. It takes a while for it to heat up, and once it is heated up, it takes a while for it to cool down. So we say that because of this, we say that it acts as Earth's thermostat. Okay, it helps keep the Earth cool. For example, you have some water here, like lake or an ocean, next to land. Land doesn't have a very high specific heat. It's going to heat up very quickly, very easily. It's going to get hotter than this water here. So what happens is we see a convection current starting to form. That cool air over the ocean is going to move in over the land, and it's going to help keep the area cool during the day because it's taking a while to hold on to that, or to absorb that heat. Now the opposite is true at night. Because the land doesn't hold on to heat very well, it's going to be much cooler than the ocean. The ocean's going to hold on to that heat, and it's actually going to bring that cool air off of land and help keep the area a little warmer at night. And this acts through yearly things as well, like the year seasons as well. So we have, here's our ocean here. As you can see at the center, you have the warm water. The redder it is, the warmer it is. So yellows and oranges and reds are going to be a little warmer. That's going to absorb all the energy coming from the sun at the equator. And it's a good thing that water is there, because without it, this region of Earth, this center region, it actually could be too hot for life to exist. We like it because it's warm, but it could actually become too warm. And we're going to see the same thing along the Great Lakes. It's going to create cooler summers for areas like Put-in Bay and Cleveland and stuff like that. They're going to be a little cooler in the summertime than Central Ohio. They're going to be a little warmer in the wintertime than Central Ohio because that water's holding on. Now, those in general, not overall, because we have other influencing factors, like winds and Arctic blasts and stuff like that coming. But in general, this absorption of heat is going to keep us cooler when we need it and warmer when we need it. Okay. Now, it can also move that water around the globe. As you see here, here's a diagram of big convection currents along our ocean. Okay, it can actually heat or cool areas year-round as needed. An example of this would be the Gulf Stream. Okay, this is going to take warm water from the U.S. up to England, and we've actually talked about this because this is what happened in Penzance. So if you take a look back at this location, you have the warm water in the Gulf of Mexico, which is why it's called the Gulf Stream. It's going to move up the coast of Florida, go along Georgia, Carolinas, and around Virginia. It's going to start going off into the Atlantic Ocean. Now, this is why we think of these states as beach states, because they have that warm water. It's going to keep it a little more mild temperature year round. Now, Pennsylvania and New York, not so much. That's why we don't think of them as beach states, at least not in the wintertime. But that warm water is going to travel across the Atlantic Ocean and head to England, the United Kingdom, which is where Penzance is. So even though Penzance was 10 degrees farther north than we are, here in Shelby, Ohio, it's at 50 degrees latitude, we're at 40, you would hear that, or you would see that it's a little warmer here, and they don't actually get very much snow in the southern part of England. Like London, they don't think of snow, you think of rain. Northern Britannia, where Scotland is, you'd have more snow, but down here, because of that warm current, it's going to keep it a little warmer. Now, these currents are going to be what we call surface currents, and that's the reason because this convection that you see here is happening more from low latitudes to high latitudes, coming from the center of the Earth down or up to the poles, but not within the water itself. The warm water's going to be on top, and it's going to stay on top. The heat source is the sun, so it's heating up the water here, and the water's expanding, but it's not rising because it's already at the top. So what we see happening is layers of temperature within our big bodies of water, like the Great Lakes or the ocean. All of that warm water is going to stay at the top, and the cold water is going to move down low. The only place we'd see really convection currents is if we have a thermal vent or volcanic action happening underneath the ocean. So we call them surface currents for there. Now, as you can see, there's another portion. We have South America. Those warm currents are going to help keep that warm. Look at how close South America is to Antarctica. We don't usually think of it as that warm, but it's because of those ocean currents there moving that water around. South Africa, even though it is higher latitude, it's still considered a warm country. So those currents are there. Now, off the coast of South America on this west side, there's actually something else happening, and it's an event called an El Nino. An El Nino is when the waters of South America, and you can see the water near the equator actually becomes warmer than usual. There's an El Nino, and then we have the La Nina here. We'll talk about that in a second. But they become warmer than usual, and it actually causes worldwide weather patterns to change. Something that we are finding out more recently. This thing is the effects of this, the international effects of this, we didn't really know about until very recently. Okay, so in some areas it causes increased rainfall. We get more wetter summers and actually wetter winters too. Not so much snow as more rain because of El Nino. And then in other areas, it actually causes droughts. Like in Africa, El Ninos lead to droughts. They come in about 2-year cycles. They flip and they flop. But actually, the La Nina is the opposite end, where we have the cooler. So we have about 2-year cycles between El Nino, La Nina. We'll have warmer and cooler, and this pattern is in general. You might hear people say, well, it's an El Nino year when they're making forecasts for the winter or looking at the Farmer's Almanac. That helps to decide what's going to happen. After ocean currents, let's go ahead and move forward. If you have any questions, feel free to message me. Okay, we're going to talk about topography and how temperatures change with that. So topography is the shape of the land. It's not just necessarily the surface, what's on the surface, but it's the actual shape of the land. It's the features of the surface, like are there mountains? Is there a valley? Do we have a plateau? Do we have wide open ranges in the plains? Topography is what shape, what height is happening on our land. A topographic map shows you where the mountains are, or the valleys, or that sort of thing. Now, you guys know that this has a major influence on climate. This is one of the very first things you said, elevation, right? Now, for every 1,000 meters that you increase, the temperature will fall about 11 degrees Fahrenheit, or 6 degrees Celsius. So it gets cooler. An example of this would be, a great example is Denver. Now, it's not that Denver's never hot. It's just going to be cooler than other parts of the country, right? Because it's that mile-high city. It's a high elevation. You also notice that in Denver, the vegetation's a little different. That's because the temperature changes. Now, tropical rainforest, they're going to need warmth right down there. So we don't really see tropical rainforest on the top of mountains. We'll see more temperate deciduous forests, and the higher you go, the more the trees change. And so when we see mountain ranges, usually we're just looking at conifers. Now this says taiga, but we're just usually, it's not taiga in the sense that it's latitude, but taiga in the sense of its elevation. So trees that are need warmer weather aren't going to survive on the sides of these mountains, right? So the higher it is, the more it is. Now, that is not the only thing that's going to affect, okay? It's actually the wind currents and the mountains are going to change too, okay? You can see that here. Let's go ahead and take a look at one of the mountain ranges here in the U.S. So you have the Rocky Mountains right here, right? There's the Rocky Mountains, okay? And then you have the Sierra Nevadas down here in California, okay? And a little further up, there's the Sierra Nevadas right there. Okay, along the coast you have, these are connecting mountain changes, the Cascade Mountain Range here. Okay, this is the part that takes in Washington and Oregon. And if you take a look here, you'll notice that one side of these mountains is green, and the other side of the mountains are brown. And that's created by this wind motion. As the air moves up, rises up the mountain, it's going to cool. And as we know, the cool side, or as the air cools, it's going to not be able to hold on to moisture, so we're going to have a lot of rain. This is why Seattle, Washington is always so rainy. Okay, it's because of this movement of the ocean, of the wind right here. It's going to let go of all that moisture, and it's going to release all that rain on this side. Okay, so this is called the windward side. Okay, because it's coming from where the wind is. Now the other side, the leeward side, has no moisture left. It lost all the moisture, so as it comes back down the mountain, as it comes onto this side, it's going to be really dry, and it's going to start to warm up. And as we know, when air warms up, it's going to start absorbing the water. So this side is what we call a rain shadow. And as you can see, if we look over here in Washington, Oregon, what do you see over here? There is a desert in the eastern part of Oregon. Why? Because of that rain shadow coming in, and it's absorbing all that land. Now, it's a big scale. We'll go back here. It also happens in the U.S. from the Rocky Mountains. You can see this is why the Great Plains exist where they do, because all that moisture has been lost going over both this mountain range and that mountain range, so we don't have very much moisture here. It doesn't start to get green again until you get to the East Coast. So that is what other influences of climate could be. Now, you've already taken a look at the other part. You've read about Mount Tambora and the effects of that. Those are things that are happening all the time. In 2010, I can't pronounce that name. I've tried to. I've actually been there. It's in Iceland. Eyjafjallajökull. I have a magnet that says, what part of Eyjafjallajökull do you not understand? That's so hard. But there was so much activity and so much atmosphere in the air that it actually stopped air traffic for 2 weeks in England because of it. So we also talked about the sun and other things, so you should have those notes. So if you have any questions, please let me know, and go ahead and start answering your questions for today's lesson. Have a good one.